Hello everyone. So this video is about Starling law of heart, Frank Starling law, or just simply Starling law. Starling law correlates the ventricular diastolic volume with the pressure that the ventricle is going to generate. In a simple sentence, we can say that the end diastolic volume of the ventricle is what is going to decide the pressure which the ventricle is going to generate. We can simply understand it by understanding a simple thing that when we have an elastic balloon and we go on filling it with the air, and once we release the balloon, air is going to blow out with a lot of force and the balloon is going to shrink. This is all because of elasticity that the balloon has. And this is what is happening in the case of myocardium. Consider this our myocardium, okay, and this is the ventricular myocardium, the atria, and this is the aorta, if this is the left side. Okay, so if we have lot of blood coming to the ventricle, okay, and this filling is going to occur during the ventricular diastole. During the diastole, ventricle is going to be filled with the blood. At the end of the diastole, whatever blood is present in the ventricle is what is known as end diastolic volume. This end diastolic volume is going to create a due to filling of the ventricle, the ventricular myocardium is going to be stretched. Okay, this myocardium will be stretched and the fibers will go on stretching of the myocardium, and until there is an optimal stretch which will create the maximum tension. Okay, this optimal stretch of the myocardial fiber will create the maximum stretch in the myocardium, and with increase in the end diastolic volume we will have increase in the force that the ventricular is going to create. In a simple language, Frank Starling law states that for a skeletal muscle with increase in the stretch, we are going to have more of the contraction until we have an optimum. Okay, this word is important, that until there is an optimum stretch or optimum tension that is being created. Similarly, in case of myocardial fiber, until there is an optimum stretch, there is going to be maximum force that is being generated. So with increase in the end diastolic volume, we will have increased pressure that the ventricular is going to generate, and this increased pressure is going to manifest in form of increased stroke volume. Okay, eventually because of this increased pressure, the ventricle is going to contract and will push blood forward and will create an output that is stroke volume. So Frank Starling law of heart states that end diastolic volume of the heart is what decides the stroke volume of the heart in case other parameters are constant. Not all, because if there are other parameters like afterload, cardiac contractility, heart rate, these factors may also decide the stroke volume, but other factors if constant, the only parameter that decides the stroke volume is end diastolic volume. Okay, let's try to understand this graph now. So we have diastolic volume here and a pressure generated, or the stroke volume you may say here. So with increase in the diastolic pressure, we have increase in the pressure or the stroke volume that the heart is going to generate with up to a limit. With this V1 diastolic volume, we have the P1 pressure or the stroke volume, which is maximum. Means at this end diastolic volume, we have the maximum stroke volume. After which, if there is increase in the end diastolic volume, the pressure or the stroke volume is rather than increasing, going to decrease. Now this is important to understand because after this volume, the stretch of the myocardium will not generate more tension, but it will disrupt the myocardial fiber. This is the phenomena that is occurring here, that after a particular end diastolic volume, the myocardial fiber are going to disrupt, so the pressure will go on down and stroke volume will decrease. Whereas in case of skeletal muscle, we have a different phenomena operating. Similarly, Frank Starling law stated that with the increase in stretch of skeletal muscle, the more force is being generated by the skeletal muscle, it will contract vigorously. But here also we see this phenomena that with increase in stretch after a particular limit, we are going to have decreased level of contraction. But here it is not because of disruption, here it is because of loss of actin myosin bridge that is formed. Okay, but this loss of actin myosin bridge is not seen in case of myocardial fiber. Here we have disruption of the myocardial fiber, which is going to decrease the pressure generated. This was important to know. Okay, The decrease is due to beginning of disruption of myocardial fiber rather than decrease in the cross bridges. So this is what Starling law of Heart stated. In a simple one sentence, we can say Starling law of Heart gave us a relationship for end diastolic volume, how it is affecting the stroke volume generated by the heart. This can be applied in a patient considering if he has diastolic dysfunction. So if a patient has diastolic dysfunction, so the compliance of the heart will be decreased, means at diastole filling of the ventricle will be decreased. Because of this decreased filling of the ventricle, a decreased end diastolic volume will be there. Because of this decreased end diastolic volume, there will be decreased stroke volume, and eventually there will be decreased cardiac output, which will manifest in many forms. So this diastolic dysfunction can be a cause of cardiac failure. Okay, this is one of the application you need to understand about the Starling law of heart, how it operates. So hope this gives some gist about the topic Starling law of heart. Hope you liked it. Thanks for watching.